Beautiful. Okay, so I'm here today to talk about zero gas, infinite scale, the bull case for app chains and how to build them. So yeah, first show of hands, who has heard of Gelato Network before here? Nice, quite a lot. Cool. So actually, I was here at ETH Dubai 2 years ago, a year ago, and 2 years ago I talked about our automation services. We at Gelato built the first decentralized smart contract automation protocol. That's like 4 years ago. And back then I would talk to you about how PancakeSwap, MakerDAO and so on have used our automation services to automate their protocol upkeep. I think last year I talked about our serverless functions, Gelato's Web3 functions, how Beefy Finance, Yearn and so on. Many other projects are using serverless environments to get, I don't know, off-chain payloads from 1inch and others and automate their protocols based on this. And this year I'm talking to you about something quite different, but it all sort of fits together quite beautifully, which is the world of rollups, rollup as a service. And yeah, I think it's quite fitting because you probably noticed that everybody and their grandmother is launching an L2 these days. And I will talk a bit about why that is the case. So I'm Luis, I'm the founder of Gelato Network. And yeah, let's jump straight into it. So first I'm gonna take you down a small trip down memory lane, and I'm going to talk about how Web 2 scaled. So at the start of Web 2, basically you had local hosting. This meant that you put your HTTP server onto an actual physical machine in your office, at your home. You would have to install software on that machine, you know, and that was your web server. And obviously there were many issues with that didn't scale because, I mean, first of all, you had to buy that machine, you had to set it up, you had to maintain it. And especially if you were building a global website, that machine was in your basement somewhere, and someone on the other side of the continent or globe even would have very slow loading times trying to reach that machine, right? So very unscalable. From there, we went to shared hosting. I don't really remember this. I think I'm a bit too young for that, but some people might remember GeoCities and DreamHost. And this really was a massive step up from local hosting. So shared hosting providers would allow you to deploy your web app or website in their shared environment online, so they were managing all of the hosting for you, the servers for you and so on. And yeah, sounds pretty cool. And the problem was still that it was very constrained in scalability and very inflexible in usability, because the shared hosting providers would usually have a framework that you were constrained by, so you would have to use their programming language. It would be quite limiting sometimes in what you could do. And worse, even worse, everyone was deploying side by side to each other. So if another app had a huge unexpected surge in traffic, you would maybe suffer from that other application that has nothing to do with you. Yeah, maybe you see where I'm going with this. So what was the end game for Web 2 scaling? Cloud VMs, basically, AWS, Google Cloud, you name it, right? So the end game was to have the hardware layer completely abstracted and virtualized in the data center, and to allow developers to use VMs like Linux and so on, virtual VMs in the cloud. And that's where we are today. That's, I mean, infinitely scalable. You know, you can bring any programming language. It's completely, you know, up to you how you want to use this. And you have auto-scale. You don't share the infrastructure with everyone else anymore per se, so you can sort of just pay the cloud provider for how much compute you need. It even allows you to do that automatically with auto-scale and elastic compute and so on. So that's really great. You know, you can literally deploy your web app now, and if you design it correctly, you can basically scale to infinity. You know, and that's been proven by big tech companies like Facebook and so on before, right? So the key takeaway here is that the internet is not one huge world computer. Actually, it's a web of interconnected computers. And Web 2 scaled via asynchronous services. So most of these services, even your own application, the instances that you run, they talk to each other usually via asynchronous interfaces, HTTP, you know, all of these protocols. Yeah, so that's basically asynchronous services were very key to the scaling benefits here. So let me try and tie that back to Web 3. And the claim here is that Web 3 will and is basically scaling via asynchronous cloud services too. So I just took you the trip down memory lane for Web 2 scaling, and now I'm going to do the same for Web 3. So in Web 2 scaling, we had physical servers in the first stage, right, at your home. This was basically Bitcoin back in the day, in 2013, I guess, and so on. When people tried to replicate Bitcoin, there were app chain developers out there, like Mastercoin and many others, who basically back then had to replicate what Bitcoin did, which meant they sort of forked it, like Dogecoin and so on, right? This was very unscalable because you basically had to replicate the success of Bitcoin, which meant you had to recruit a massive validator network of miners and so on. You had to inflate your own coin to pay them and so on and make that all work. And that basically wasn't scalable at all. And that's why Ethereum was invented, right? We went from launching your application as a chain, as a proof of work chain, to launching your application as a smart contract on top of Ethereum. And that was like insane innovation, and it was really great, and it really helped the space get to where it is today, and those many application developers to exist, right? But there are problems with Ethereum, right? We know that. So again, similar to Dreamhost and GeoCities, application developers have to share this space, this compute, right? And that means if some crazy NFT mint happens or some ICO, your users might suddenly suffer huge degradation because gas is going through the roof, the network is congested and so on, and now your application suffers from something that you have nothing to do with. And also, similar to shared hosting providers in the web, Ethereum is very constraining, right? Like EVM, Solidity and so on, that's very limiting. You can't build you can't build very powerful applications with that. Maybe a few good examples would be Uniswap and so on, but outside of that, it's very hard to build powerful applications on top of this EVM platform. We know that EVM itself has many shortcomings, it's not parallelizable and so on. So that's basically not very scalable, and that's why we had to invent rollups. And rollups, you could really liken them to VMs on AWS or something. You can think of a rollup as a virtual blockchain. It's a blockchain inside a blockchain, sort of. Rollup as a service providers like Gelato basically are like AWS, where you can spin up many instances of a virtual Ethereum, OP, Arbitrum, whatever you want, right? Your instances, just like you would spin up instances of Linux and so on AWS. And you can easily configure the VM as well. Like, that's not being done much today, but it will, I think, very soon happen, that you won't just have vanilla OP anymore, like vanilla EVM OP or Arbitrum. Actually, Arbitrum, for example, already has stylus and so on. So yeah, you will see parallelized EVMs like Monad and so on technology being used. You already today have rollups like Eclipse that use Solana VM, but they settle on Ethereum and have DA, Celestia for DA. So really, the developer can now come again. They can bring a powerful VM, like I mean, Cartesi, for example, they're working on fraud proofs for Linux VMs. So maybe for the first time we can write blockchain applications in a Linux environment, which is like the holy grail. And even more important, you have a sort of virtualized service like Gelato Rollup as a service, where you can spin up as many as these as you want, and you can scale them to your needs. So that's basically the end game for Web3 as well. And we're not quite there yet, but at Gelato we've seen like 10, 20 chains launch on our platform only this quarter, and it's really happening. Like many applications are moving away from smart contracts on a layer 1 or layer 2, and they're going onto their own block space to be able to have dedicated block space, to not share it with the other applications anymore, and to only have scaling needs when they actually have their own traffic they need to scale and not some random other applications traffic. So you can think of Gelato as the Web3 cloud. We have built middleware services, automation, account abstraction, relaying, all the stuff serverless in the past. And now we're bundling all of these up together with your own dedicated VM and block space. And I'm going to now go into some technical architecture. It's very high level, so it's not very technical, to be honest. But yeah, you can roughly think about it this way when you want to basically create your own role app. You have the base layer that you can pick. So base layer would normally be the execution engine, and obviously Ethereum itself, but the execution engine like OP Geth or Arbitrum or Polygon CDK, the data availability layer, the data publishing layer like EigenDA, Celestia, Avail just launched, right? We did an event with them here in Dubai. And on top of that, so that's like the block space and the sequencing, the compute. On top of that, you need a bunch of servers for your block space to be useful, right? Like, so you need Gelato Relay, serverless, maybe if you want to talk to oracles like Redstone or Pith, they all use usually Web3 functions to get the data from off-chain to on-chain. You need block explorers like Etherscan or Block Scout for sure, right? Bridging. So you really have this sort of basic roll-up stack that we provide you with, but it doesn't end there. You really, when you launch your application as a chain or a smart contract, you need all these other services as well that before you took for granted, right? Like when you launch a smart contract on Polygon or on Ethereum, you get the graph there, it's already deployed. You get Etherscan there, it's already deployed and so on, right? Here, when you enter your own dedicated block space, that is not the case anymore, but we are there. We have all of these suppliers and our own services ready from day one so that you can create your app as a roll-up on day one, and you have bridging, oracles, everything included same day. Just like on AWS, where you have your MongoDB and whatnot ready, Stripe maybe even and so on, ready sort of in a sort of Lego brick way. So here's a quick video for how easy it is to create your own rollup. You just hit deploy, give it a test name, pick your stack, pick your DA layer. Yeah, you can configure some options like on-ramping, fiat on-ramping, you deploy it, and bam, it's ready. So yeah, next week, by the way, we're launching base L3, so you can also build your application as a base L3 and be connected to that ecosystem, which is popping off right now. You can see the integrations you have on there, like layer 0 and so on, we support as well. Yeah, pretty easy. Try it out. All right. So essentially, you probably heard this a lot. All of this is about the modular blockchain design. And where before we had Ethereum, the singleton monolithic execution layer and data availability layer, we have, with rollups, separated the stack into a settlement layer, Ethereum, which is also functioning as a data availability layer, especially now after blobs are live. And we have separated out this settlement layer where you basically store you still deploy your ERC20s there, right? Like you have, like basically the asset layer, I sometimes call it decentralized asset layer, but you put them into a rollup bridge. And the rollup itself is the execution layer. The rollup basically runs the state transaction.
Can I ask a question, like while we're waiting?
Yeah, sure.
So I have a talk on UX and DX, kind of in Web3, and kind of in your words, what is Gelato doing to kind of advance, I guess, developer experience?
Yeah, it's a good question. So, I mean, it's actually interesting. So before rollups, we approached this from the services point. So like 3 years ago, we released our Relay API, which allowed you to send gasless transactions. It was used by account abstraction SDKs like the one from Safe, for example, and others. And that was nice. Like back then, I already wanted developers to start paying for the users' transactions so that we could do away with gas and users just go back to clicking buttons. And especially with wallet as a service providers like Web3 Auth, Privy, and so on. This was really great. We had many nice demos where people would just sign in with Google. They would buy an NFT maybe with credit card and they wouldn't even know that there was a blockchain underneath. But in reality, this never really took off that much because most blockchains were still too expensive for a developer to be able to pay for all of their users' gas. So actually what I realized is that with rollup technology coming on the market and also being the way that Ethereum decided to scale, we can now go to the base layer and we can create this block space ourselves at Gelato, the cheap block space for you, where for the first time it's possible, even for smaller projects, to just pay for all of the users' gas. That's especially done, not maybe with an Ethereum L2, but more like a Validium or Optimium or whatever you want to call them. So having something like Arbitrum DAC, the Nova thing, the antitrust thing, we have like 3 or 4 chains launching this month that all use this, and they basically pay zero gas. We call them zero gas rollups. So that helps a lot. Like actually going to back to the base layer and making sure that gas is cheap, that this stuff scales is, I think, the biggest unlock we had. And you know, that's better than any abstraction that we try to fit on this in the past, because you cannot abstract away the costs. Someone has to pay them at the end of the day. So best way is to actually just reduce the cost. There's a question there. Liquidity fragmentation.
Yeah, so there's going to be like hundreds of L2s using Gelato. do you guys have any way in which you are going to be addressing the fact that with each of those L2s, you're going to need bridging, you're going to need like, different dexes or whatever, and maybe there's some stuff you have in the works to help kind of not make things super fragmented?
Yeah, so I mean, liquidity fragmentation is one of the bear cases for the world of, hundreds of thousands of rollups, but there's a lot of technology that can fix that. I would say every entrepreneur out there, this is the same in Web 2 and so on, you still have a duty to attract as much liquidity as you can, right? Like that's just the homework that you have to do. You have to build a brand, you have to attract the liquidity, you have to, nowadays people do points and whatnot, right, to bootstrap systems. That's a reality that you cannot run away from, and I believe that there is going to be some power law where, the top 10 rollups maybe have the largest share of liquidity. First of all, there's a bunch of use cases that don't need liquidity per se, like a lot of the gaming use cases don't really care about it. Some of the NFT use cases don't really care about it. So there's this world, but even in the DeFi world where liquidity is king, it's really a bootstrapping question. So if you are big, you're going to get liquidity, right? If the next Binance is going to be a roll-up system, then they will attract the liquidity. For those that are trying to bootstrap, it is nice to be able to tap into Uniswap and so on, right? You lose that benefit when you're on your own rollup. But we are working with Espresso, for example, on shared sequencing technology. Awesome, we're back, by the way. Where actually there is in research at least, very exciting primitives now, like base sequencing and so on, that we're also working on, where it is feasible, at least being theorized about, that you can have a rollup that synchronously taps into the liquidity of L1 or another L2. So maybe you can launch an application on a rollup and you can have synchronous cross-chain calls and atomic execution where it is possible to process transactions on your rollup that source liquidity from elsewhere. And that's the holy grail, synchronous cross-chain composability. But even without it, I think having a very nice ZK technology that's entering the market, like Polygon CDK is already sort of leading the way there with the egg layer. We're running that as well, and they are having super fast asynchronous calls, like the Web 2 did basically. I think that's also going to work for a lot of the use cases. It doesn't support flash loans and so on, but it's not worth throwing all of this away just to support flash loans. I think they're cool, but they're not that important at the end of the day. So yeah. Anyways, back to the presentation. Thanks a lot for fixing that. So yeah, the core blockchain design is now all about modularization, and rollups are running basically the execution layer. We have the assets on Ethereum, the settlement layer, and we have a DA layer. Could be Ethereum or could be Celestia, EigenDA, Avail. And that's how we split up the core blockchain stack. Yeah, it works if I point it there. Cool. So now, beyond that core blockchain stack, we now need to add a layer of the essential infrastructure. So those are RPCs, right? Like we run our own, but we also work with RPC specialists like DRPC, for example. And you also need a native bridge UI. The rollup stack actually comes with that. So that at the very least you can bridge ETH natively from Ethereum to the rollup or from Arbitrum to the L3. And you need a block explorer. So, and now we're really adding this layer that sets Gelato apart from every other rollup as a service provider out there, which is, okay, you also need a bunch of other essential Web3 services beyond the basic ones to really build great applications. So for example, we have functions. If you know AWS, this is AWS Lambda basically, or if you are with GCP, I think their thing is called Cloud Run or something. So yeah, you can use our serverless functions, and this is really great, not just because, with serverless lets you basically build anything, you connect to any resource on the internet, your databases or whatnot, and then publish data based on that on-chain into your application, but especially because modern oracles like Pyth and Redstone and Dion and others, they're all basically combining our functions with their data to be able from day one to publish their data on-chain. So now you can build a perpdex as a rollup, launch it, and same day hook into Pyth or Redstone data and have it be pushed on chain. And you don't need to pay these huge Oracle gas costs anymore because literally on your block space, if you go for like Arbitrum, AnyTrust, or I don't know, something else like Celestia, EigenDA with any of the stacks, gas is so cheap that you can feasibly pay for every Oracle update. Yeah, Relay is great as well. You can add your deb UI on there. You can have Relay together with, I guess, one of the account abstraction SDKs, Safe SDK, for example. and so on, and you can build great applications now on your rollup that actually, let the user sign in with Google and click buttons, and they don't even have to know that there's a blockchain anywhere. And we also work with indexers that are, of course, important, the Graph, Goldsky, and so on. And yeah, here you see that what's really crucial as well are like cross-chain messaging services like Layer 0, Connext. There's many of them that we work with, and they let you also not just move assets from Ethereum to your rollup, but also from other chains. So if your users are coming from Base or coming from Optimism or whatnot, you can all move them into your rollup via one of these services. And this is also the part that's quite interesting because these asynchronous messaging services also let you connect to other chains, right? So this is also like the example I gave earlier that in Web 2 you can have multiple instances that talk to each other asynchronous. This is also like technically you don't just have to connect to other chains here, you can also connect to your own instances. If one rollup instance isn't enough to process all of your transactions, like for example, let's say you're building World of Warcraft, some type of World of Warcraft on chain. If you ever played one of these massively multiplayer online games, you know that maybe some of your friends were playing on a different server, right? Like so similar here, you can have a huge game, you can have 10 servers across, like maybe one is the US server, one is the South America server, one is European, Asian server, and you players can play on these rollups. And yeah, maybe if one player needs to interact with another player, at the worst case, they would just have to transfer their assets via one of these cross-chain messaging protocols to that other server and continue playing there. So yeah, that's the horizontal scaling what I just described, basically. In the asynchronous way, and there the holy grail really is, back to your question about liquidity fragmentation, is have this be in a non-asynchronous way, in a synchronous way, and that's where shared sequencing comes in. And there the idea is that you can run multi-instance rollups, like 3 instances of OP, for example, but your smart contracts, it's basically like sharding, your smart contracts can still call each other cross-instance synchronously. So yeah, this is like, one of the current most exciting research areas. You probably heard of projects like Espresso, base sequencing. Justin Drake is talking about it a lot recently. And yeah, that would be really great because then, you can essentially run a horizontally scalable, maybe even parallelizable instance where transactions are processed in parallel, but they all modify the same state. And yeah, maybe that's another way to scale rollup stacks like OP and Arbitrum and Polygon above the current limits. I don't know where they are exactly. I think it's something like 500 or 1,000 TPS to like beyond 10,000 TPS. And we're heavily researching that and seeing whether we can get that done. And I'm quite confident that by the end of this year, we will probably have the first proof of concept on mainnet, and by summer already first testnet. So yeah, Ethereum is therefore not one huge world computer. Just like Web 2, it's a Web3 of interconnected rollups. And you can build your own rollups. I really encourage you to launch your next application as a rollup, not as a smart contract anymore, to really benefit from these scaling benefits, from having your own dedicated block space. Yeah, there's many other nice things that come with being your rollup. There's a lot of difficulties, a lot of heavy lifting, but Gelato does most of the heavy lifting for you. We're here to help. We have most of the infrastructure already figured out. And yeah, for you it's more like, click of a button type scenario, and then you can just build your application and have your own block space. And still, the beauty of rollups is you're still connected to Ethereum with a trust minimized bridge. That's the whole purpose of rollups. With Optimism, you have fraud proofs, right? With the ZK rollups, you have ZK proofs that allow you to connect to Ethereum and move assets back and forth in a very trust minimized way. And even if the rollup operator is somehow faulty or fraudulent, allow you to exit the TVL or the assets on the rollup back to Ethereum, so that you don't really have to trust the operator much, at least not for your asset safety. So yeah, and inviting you to come build on Gelato. And oh yeah, I think that's a special slide that's new. So we also have node sale as a service. That's actually very interesting. If you're launching a token, many of the games, for example, do. Nowadays, what we're seeing as a big trend this year is if you launch a token on your own L2, people were talking a lot recently about ICOs, whether they should come back. That was like the 2017 era. Nowadays, most token launches are airdrops or similar. But yeah, we see like a new way for token sales to make it back in a more compliant way. making really sure that the token is a utility, and having your own L2 is a really great way of achieving that by, for example, having an ecosystem of nodes that need to perform certain services on that L2. For example, with optimistic rollups, you might want to have verifier nodes, watchtowers that actually sync the chain and make sure that there's no fraud on there, that report frauds, that post challenges if fraud is detected or faults are detected. So yeah, if you're launching your own L2 and you want to be a bit more decentralized, maybe it's a DeFi protocol, maybe it's a game or whatnot, we have node sale as a service where we give you these verifier nodes and other nodes. We can even build nodes with you based on what you want to do with them. And the way the token sale then works is that you can, the community of investors that want to participate in it, they would buy a license to run these nodes and then they can mine the token, right? So you sell these licenses instead of the token, and they would then, you know, run these nodes and prove that they run them and mine the token over a period of two years or whatnot. So this was actually pioneered by something called Zai. They're on Arbitrum L3. It's really cool. I think they did a big race there, and we see many, like 5 or 10 projects, or many more doing this now. And yeah, if you're also interested in that, we can help you with that. Yeah, so last but not least, that's our ecosystem map. Lots of projects on here, definitely not all of them, but yeah, for example, we already obviously work a lot with Optimism. They use our automation as well, and Polygon and Arbitrum as well. We have Asta ZK EVM live, that's the first production Polygon CDK egg layer chain. Yeah, I mean, most of these projects use our automation services, serverless services, Relay or whatnot, like Beefy, Yearn. You know, Safe, we work with a lot, Connext, Stargate, Synthetics, all of these guys. So you're in great hands if you wanna build with us. I invite you to join our Discord, follow us on Twitter, Gelato Network. Hit me up, I'm gonna be here all night. My flight is leaving 1 AM, so I'm gonna be here for the after party and so on. Happy to talk to you guys. And yeah, thanks a lot for coming to my talk.
Absolutely, thank you so much.
Should I answer a question or should we end it here?
We can do more Q&A if you want to. Do we have our next speaker ready to go? Let's do Q&A.
All right.
So do we have any other questions for Lewis? Roll up as a service? Here, let me get you a mic.
Could you please bring back the last slide?
I can't from here. You want to go back a slide?
Can you put up the last slide?
The QR code.
The QR code?
Don't worry, it's also on our Twitter, by the way, Gelato Network.
Did you have any follow-up questions? No? Here we go.
One question there.
Hey, yeah. So I think towards the end you mentioned the node sale as a service. One of the second to last slides. Curious how that works. Are you allowing partner teams to define the infrastructure definitions to be able to run these the node infrastructure? Or are you guys actually just doing the research to figure out how to do it yourselves, and then kind of posting from there?
So we are mostly backend and infrastructure specialists. So we provide the nodes. Like for example, if you want to run one of these optimistic verifier nodes, we have them ready for you. If your user base or investor base is a bit more technical, they can just run it as a Docker file themselves. But we also have a sort of nodes as a service where, like in a serverless environment, we're actually leveraging our own Web3 functions for this. You can just like sort of have a clickable interface to deploy this node, run it, connect to an RPC and so on, and then start, you know, mining the token. For the front end side, we're working with Impossible Finance. They've sort of pioneered this. They have white label solutions there for the actual conduct of the sale, I guess. So yeah, and we will have the first ones of these node sales going live next month. So it'll be exciting. Yeah. Cool, thanks.
Any other questions? Raise your hand.
I think that's it. We already had some questions.
I think roll-up as a service is an interesting concept. I think most people who want to start a roll-up, this kind of opens up the opportunity for anyone to do that. Are there any drawbacks to doing it on Gelato? And why, as a dApp developer, I guess, and you kind of already covered it, but what's the benefit of me creating a new application to do my own roll-up?
So drawbacks, I don't think so, because it's really about economies of scale. So yeah, you can run your own rollup, but we run already today 50 or so of them, and we are actively investing in that, and that just allows us to bring the cost down. Just typical cloud economy of scale. Now, there's some trust involved, right? But there's ways to mitigate this. We are working on more decentralized sequencing technology as well, where you can run your own fallback sequencers. So if ours is down, for example, you can spin up your own one. So you can fall back to your own servers if you want to. That's not quite ready yet, but will be ready soon. But yeah, that's pretty much it. Other than that, I think it's just the more scalable model to use this as a service. And the second question was like benefits, I think, of it. But yeah, there's another question there.
Yeah, just want to go back to shared sequencing. How much harder does it get to do shared sequencing as the VM space starts fragmenting? So can you run shared sequencing between, say, Monad's VM and Eclipse? Like, I can imagine if you have EVM equivalents, it's an easier problem. But like, I wonder what your thoughts are on like how that problem space explodes when these guys are all doing crazy stuff.
It's a good question. So, I mean, take this with a huge grain of salt because this stuff is just in research. I did an episode with the founder of Espresso last week. It's on the On Gelato podcast on Spotify. We go really deep into that question, 1.5 hours on Gelato on podcast on Spotify. But yeah, basically, I think there is a way for shared sequencing to be multi-VM, because shared sequencing layers like Espresso are basically just like the A layers. You can think of them as like similar to Celestia. They just order transactions, and this is just like blobs of ordered data, right? So it doesn't really know what a VM is per se and so on. It's just like its own sort of blockchain that orders data. It's like, this is hyper-modularization. So at this point, we separate out the consensus from like, and technically you just need an execution layer on top to process this data, and this execution layer is the VM basically, right? Like, so technically shared sequencing itself is just ordering the data, and it's just data, right? So it's very generic, very general purpose. And so this blockchain can host many different types of data, and then you just need a execution engine to be able to process all of it. And that's where PBS comes in. So ultimately, yes, I think it will work. You just need, again, like with PBS, you need very sophisticated, beefy builder entities that know how to do that know how to run these different VMs, that can do that, and that can also generate proofs for that and so on. That's like where the rollup as a service comes in again. Yeah, so ultimately, there is going to be a form of centralization to support all of this. But just like with PBS, the idea is to offset that by having a shared sequencing is maybe the wrong word. It should be called shared proposer, I think, where then, you have a lightweight nodes that can, at least propose the blocks that are built based on this. So yeah, some form of PBS and so on should solve this, I think. By making trade-offs, right? There's no free lunch, but yeah. All right, cool.
All right, thank you so much, Louis.
Thank you.